So Iceland went through a very difficult time in the 1970s when oil prices, there was this tremendous shock of oil prices globally. Iceland found itself with some hydroelectricity generating capacity, but a lot of it was oil produced. And as a result, they ended up recognizing that they were exposed to global markets in a way that was not helpful to their economy. They really took a hit. But they also realized that they had alternatives. And I think in many ways, this is a really important lesson that when you're faced with a really difficult situation, you have to reassess everything and go back to first principles about what do we have as resources. And so what they did was they realized that they were sitting right on a tectonic plate, two tectonic plates coming apart in the middle of the Atlantic Ocean, and they had a lot of geothermal energy. And so after the oil shock in the 1970s, they decided to very actively exploit this resource, develop it, and today they have 100% of their electricity comes either from hydroelectricity or from geothermal. There might be a bit of wind as well, and some of the more isolated communities, they still will use a very little bit of oil, but they've pretty well supplied the whole country with energy, not just electricity, but also heat. They pump the hot water that they take out of the ground long distances to cities like Reykjavik, and they heat the whole community that way. I think as Albertans we can take a lot from what Iceland learned in the 1970s. First of all, they really hit a wall. They had a very difficult time when oil prices went through the ceiling. And what they did was they looked around and they sort of picked themselves up off the floor and got back at it. And really tried to understand what they had in terms of resources and how they could make the best of that. I think as Albertans, we have immense resources of all kinds. We have a very talented human capacity in Alberta. It's a well-educated workforce. It's very resilient, very tough. People have been through good times and tough times, and people are resilient as a result of that. And so we need to use all of these tremendous resources that we have as Albertans to pick ourselves back up, reassess the landscape, and then take a fresh crack at how we make use of the resources in this province.
The potential in Canada is quite immense. We have 0 megawatts currently operating for power. However, we do have about 13 small installations for the direct use of heat. But I'll talk mostly about power. We think from an industry point of view that 5,000 megawatts could be built by 2025. And that just sounds like, how could you get 5,000 megawatts going from 0 all the way in just a few short years? However, there really is that much potential available from existing operations, and we call that co-produced fluids. In Alberta, we're probably looking at between 2,000 and 9,000 megawatts of readily available resource. In BC, it's much larger. We're looking at anywhere upwards from 5,000 to 15,000 megawatts. I think it's important to recognize that geothermal, the word, is a lot like the word petroleum. And we have evolved in thinking that petroleum could be oil sands, it could be oil, it could be natural gas, light natural gas, sour natural gas. Geothermal itself are many different types of resource. So in Alberta, for example, we have the Rocky Mountain Trench and the Rocky Mountains, which is a hot and a wet rock. So Banff would be a good example, the hot springs there, Jasper, there's also warm springs in the Canmore area. So again, thinking hot and hard rock, but wet and fractured. And then you have the type that is the oil company type. So the hot sedimentary basin, which is part of the Western Canada Sedimentary Basin, which is one of the largest aquifers in the world, it itself is warm. In some places it's hot. So for the past 100 years, oil and gas holes have been drilled. However, they've been relatively shallow. And the shallower you are, the cooler it is. But now as that industry, the oil industry itself matures, they have to go deeper and deeper. So for example, Gulf of Mexico, they're drilling 10-kilometer wells. We're not quite there yet in Alberta, but our wells are approaching 5 and 6 kilometers. And so we've actually drilled through softer rock that are pools of natural gas, oil, and water. And we have found all the geothermal that Alberta needs, especially if you're thinking about substituting geothermal power for baseload coal power or even baseload natural gas power. And it's just because the oil industry itself has matured and gone deeper for their resource that we're taking advantage of the natural gradient of the earth. So for every 100 meters that you go, it goes up by about, every 1 kilometer goes up by about 30 degrees Celsius. So 30 times 3 is approximately 100 degrees Celsius. That's the temperature of boiling water. And if we're drilling into the 3 to 4 kilometer range in Alberta in that softer rock, you want to take advantage of the 400,000 active oil wells and gas wells that are happening right now. It requires, though, a change in thinking about this resource. Many people approach geothermal. Everything, of course, is bigger is better because of economies of scale. But to take advantage of existing infrastructure, smaller becomes beautiful. Because now we're talking about microelectricity. The oil or gas well has been drilled. It has a set diameter of pipe. But of course, the beauty is the money has been spent on drilling that well. And the equation for making power is really just two variables, temperature times flow. So even though at depth we can approach that temperature that we want, the flow rate will be restricted by the size of the oil and gas well. And so those wells can only produce micro power. And what we're suggesting is keep on producing the oil and gas. However, in a conservation type of approach, if the water or fluid coming up is hot enough and it can make micro electricity, you can sell that too. The AESO and the Alberta Electric System Operator is now charged by the provincial government to go ahead and look at microgeneration rules as well as renewable power prices. That will be coming out in fall of 2016. And I think now, even though it's micro power, that times a renewable power price, which will be a premium price compared to grid power, will make a good business case. I think you'll be fascinated by the answer because it's the unusual suspects. I would like to engage the food industry. It's not just about power, decentralized power, it's about decentralized food as well. If all this heat is coming up from the well, you can't really move heat around. When it's a very high pressure, high temperature steam, you could move heat maybe 4 to 10 kilometers, but that's not what we're producing. So what are we going to do with bathtub type water? You're instead going to bring industry to the well. So you think about wellhead greenhouses or 4-H clubs or local municipalities or just food security in general. Again, decentralized food, these aren't going to be large farms, but on a section of land, maybe there's already 1, 2, 3, 5 wells drilled in a section. Great, there's 5 greenhouses right there. So that's one unusual suspect. The other one would be AESO itself, the transmission operator. We really want to inspire them that we can save new builds of transmission. And so while my power is useful, saving perhaps billions of dollars on not having to build new transmission to new power sources is in the public's best interest. And that is another variable that you could add on perhaps as a price signal to the renewable power if it's able to then offset another source or another transmission line.